So a section we'll briefly touch on now, but we'll come back to in Chemistry 106 when we talk more about osmosis and the movement of molecules across semi-permeable membranes when we're thinking about cells, is what happens to ions in solution. Ions, when they form in solutions, are called electrolytes. So these can be any kind of ions. So usually salts are going to form the ions, right? You've got ionic compounds, and these, when they dissolve in solution, they're going to dissociate and form their charged components, or their ions, right? So if you had sodium chloride in the water, the sodium is going to separate from the chlorine, and you'll get a sodium ion that's positively charged, and you'll get the chloride ion that's negatively charged. So these are called electrolytes because they can conduct electricity through that solution. So strong electrolytes are going to be substances that ionize completely when dissolved in water. They form their ionic components. You can also have weak electrolytes that are substances that are only partly ionized in water, which means that they would partly stay together as well. And so they're going to be weaker electrolytes, or conduct electricity more weakly within that solution. Non-electrolytes are things that can dissolve in water, but they don't produce any ions when they dissolve. So typically molecular compounds, or things that form covalent bonds, are much more likely to be non-electrolytes. So things like sugar molecules, for example, would be a good example of a substance that would be a non-electrolyte. They do not have charges, and they are not good conductors of electricity in water. So you can also have electrolytes in the blood and other body fluids. So we also have electrolytes, and you hear a lot about this in probably the commercials that you listen to, that after you work out, that Gatorade is going to replenish your electrolytes. So that's actually what it means. It's putting the salts or the ions back into your body that you would sweat out during your workout. So our blood and our other body fluids contain many different types of anions and cations that make up these electrolytes inside our body fluids. So to discuss such mixtures, we use a term that are called equivalents of ions. So we're just measuring the total charge state then inside the blood cell. And so you'd have an equivalent charge, or an EQ, for the ions, or the amount that would be equal to 1 mole of charge. So you can have a gram equivalent for those ions, or the molar mass of the ion divided by the ionic charge. So our clinical chemists would use milliequivalents of ions rather than equivalents to denote concentrations that occur within the bloodstream, because this is a more useful term because we have usually smaller concentrations of ions inside the bloodstream. So this table is just showing you some of the major electrolyte concentrations within blood plasma. So we can look at different cations, things like sodium and calcium, potassium and magnesium levels. You can get the concentrations within the blood. And you can see that oftentimes there's ranges for these concentrations. So sodium, for example, will range between 136 and 145 milliequivalents per liter. And so for sodium, for example, there's a range of a healthy individual between 136 and 145 milliequivalents of sodium per liter of blood plasma. So again, you've got a concentration that you're looking at. You can see for specific anions, like the chloride anion, or the phosphate anion, or sulfate anion, that these concentrations are going to have ranges for these guys as well. So if you have significant changes in your electrolyte levels, these can be potentially life-threatening if not addressed quickly. So cholera, for example, can result in dehydration and very low sodium levels in the body, or hyponatremia. And this can be very, very dangerous because you need sodium ions to send electrical charges through all of the neurons in your body. And it's also utilized for the movement of many molecules through the cell as well. So one of the dangers of becoming infected with the cholera bacteria is that you can get this severe dehydration and very low sodium levels. So restoration of the electrolytes is often accomplished then by oral rehydration therapy or replacement of these electrolytes in fluid supplements. So plain water works well to replace the sweat that's lost during short bouts of activity, but a carbohydrate electrolyte beverage is going to be superior for longer activity, and it's going to be required for something that's actually depleting the body of specific ions. So nutritional research has shown that a serious sports drink should meet the following criteria. It should contain 6 to 8% of a soluble complex carbohydrate, about 15 grams or so per 8-ounce serving. It should also contain electrolytes to replenish those that are lost in sweat. It should be non-carbonated and should not contain caffeine, and it should taste good so that the athlete will want to drink it. So some sports drinks also contain vitamins, things like vitamin A, vitamin C, selenium, and glutamine, which appear to help lessen the lactic acid buildup that can cause muscle soreness. But if they do contain vitamins, you have to be a bit careful because you can overdose on vitamins, especially ones that are fat soluble, like the vitamin A. So you want to make sure that you're not taking too much of your vitamins in an electrolyte solution that you're drinking. So only drink the daily recommended amount, or limit yourself to sports beverages that do not have vitamins also associated with them.